Welcome to the deep dive. When we talk about global energy, it often sounds pretty simple, right? Like out with fossil fuels, in with renewables, done. But what if the real story is, well, a lot more complex and maybe even surprising?
Oh, definitely. It's not just evolving. The energy landscape is making a big strategic pivot. It's moving beyond that simple either thinking.
Exactly. So today we're taking a deep dive into something our research team has been tracking. They call it green code, hot core. And look, it's not just a catchy name. It signals a real shift in clean energy strategy. We're talking prioritizing power sources that are high density, reliable, firm, and geographically compact.
Right. It broadens the focus beyond just low density intermittent renewables like wind and solar.
But it's crucial to say this isn't about ditching renewables, is it?
No, not at all. It's more like an integrated strategy, an evolution, using all the clean tools in the toolbox, but maybe, more smartly, more effectively.
Got it. And the research team, they've been really busy. They pulled together a whole stack of reports, data, announcements just in the last week or so. And what they found is this, major convergence. Technology policy, investment, all pointing towards this green code, hot core idea.
A confluence.
Yeah. So our mission today, pull out the key insights from all that research, cross-corroborate what we're seeing, give you a clear picture of where clean energy is really going, especially this surprising comeback of these high-density options. So let's get into it.
Let's do it.
Okay, first segment. Let's look at the hot core technologies themselves. The breakthroughs here are honestly pretty remarkable. We keep seeing small modular reactors, SMRs, really expanding what they can do. Take now scale. There's 77 megawatt electric modules.
Those are the ones certified by the US NRC, right? The only ones so far.
That's them, and they're looking way beyond just making electricity now.
Yep. Yeah, the research really highlights their move into integrated energy systems. It's fascinating. They can produce, get this, 150 million gallons of clean desalinated water every day, enough for a city of 2.3 million people.
Wow.
But here's the really clever bit. They're looking at producing hydrogen, non-electrolytic hydrogen from the leftover brine, the waste from desalination.
Okay, wait, so they take the salty wastewater.
Exactly. And turn it into hydrogen. It's a kind of circular economy solution, turning waste into a valuable product. That's pretty innovative.
Turning waste into value, that's definitely a theme we're seeing. And it's not just no-scale making moves. Over in the UK, Rolls-Royce SMR is now the preferred bidder for their national program.
Right. Their design is bigger, 470 megawatts electric. And their big innovation, according to the reports, is this 90% factory-based construction.
Modular, right. Build it in a factory, ship it out.
Yeah, the idea is to really slash build times and costs, hopefully. Make it faster, more predictable to deploy these things. And the UK is putting serious money behind it, like £2.5 billion, aiming for grid connection in the mid-2030s. It shows they're pretty serious about advanced fission.
Okay, so the reactors are advancing, but what about the fuel? The research keeps pointing to this bottleneck, HALEU, high assay, low enriched uranium.
You need HAU for a lot of these advanced reactor designs to be commercially viable. And yeah, the supply just hasn't really been there. It's been a major hurdle.
So how do you scale up advanced nuclear without the fuel?
Well, that's where companies like Nusano come in. They're based in Utah. They just launched a commercial HALEU production program. That's potentially a game changer. And their process, it's proprietary. It apparently gets rid of the need for hazardous uranium hexafluoride, UF6. That's the stuff normally used.
Ah, so safer and maybe more efficient too.
Seems like it. And they're not thinking small scale. The goal is up to 350 metric tons a year, starting around 2027 to 2029, which, lines up pretty well with when we expect SMRs to start deploying. The whole ecosystem seems to be maturing.
Okay, reactors, fuel. What about storage? Because you can't talk clean energy without storage, especially with intermittent sources. And AI data centers demanding huge amounts of power now.
Absolutely critical. And lithium-ion batteries, great for your phone, great for short bursts on the grid, but for long duration, days, weeks, they have limitations at grid scale.
So what's stepping up? We saw some interesting stuff on thermal storage.
Yeah, thermal's getting a lot of attention. BioLargo's Salinity battery, for example. It's molten salt. The stacks look impressive. Over 500 watt hours per kilogram energy density, 95% efficiency. No thermal runaway risk, which is huge.
And made from common materials, recyclable, 20-year lifespan.
Yeah.
Checked a lot of boxes.
It really does. And then there's Malta Inc. They're using pumped heat technology, designed for really long durations, like 8 hours up to maybe 200 hours. And they just got major backing from BBVA, the big Spanish bank. That's a serious vote of confidence from the financial world. Shows these non-lithium options are gaining traction commercially.
Right. And what about fusion? The ultimate prize, maybe.
Fusion. Yeah, the research suggests that sort of a pragmatic realism setting in alongside the progress. The big international project, ITER, they're now targeting their first main fusion operations, deuterium-deuterium, for 2035.
So a bit further out than maybe originally hoped?
A bit, yes. But it actually underlines an important point. While fusion is the long-term goal for many, SMRs and advanced fission, they're the high-density, zero-carbon tech we can actually deploy at scale in the next decade or so. That critical 2030-2040 window. They're essential for near-term decarbonization.
But the private fusion scene is, like, exploding, isn't it?
It really is. Commonwealth Fusion Systems just raised, what, $1.5 billion. Helion Energy signed a lease for its first plant up in Washington. They're aiming for net electricity this year. And they have that power deal with Microsoft lined up for 2028.
A power deal with Microsoft. That sounds like they're serious about commercial scale, much sooner than people thought.
It definitely signals that. It's a big step from lab experiments to actual grid power. Plus, you've got Germany's Wendelstein's 7X Stellarator setting records. And our research team confirmed that Astral Systems, a UK company, became the first private firm to actually breed tritium in their test reactor. Tritium is a key fusion fuel.
So you've got these big public projects taking a steady, maybe slower path, and then all this private money chasing different, faster routes.
Exactly. It looks like a kind of parallel strategy globally. Bet on advanced fission for the medium term because we know it works and it's getting better and cheaper. But also fund a whole bunch of competing private fusion ideas for the longer term. Hedging bets, maybe?
Okay, fascinating tech developments. You know, this deep dive into green code hot core is really just scratching the surface of what's happening. If you're finding this insightful, maybe take a moment to like this video, subscribe to Tomorrow Unveiled on YouTube, and definitely hit that notifications bell so you don't miss our future updates.
And for those listening on audio.
Right. If you're on Apple Podcasts, Spotify, wherever you get your podcasts, we'd be so grateful if you could leave us a rating and a review. It honestly makes a huge difference in helping new listeners find the show.
It really does.
Okay, so we've talked tech. Now let's shift to policy and investment. Because the tech doesn't happen in a vacuum, right?
Yeah.
How are governments and money actually accelerating this shift?
Well, the U.S. policy landscape is seeing some pretty dramatic potential changes. That Senate Finance Committee proposal, the One Big Beautiful Bill, or OBB.
Yeah, the research team flagged that as a major overhaul of clean energy tax credits.
It really is. And the striking thing is the divergence it proposes. It would extend full credits for nuclear, geothermal, hydropower, battery storage, all the way out to 2033. But for wind and solar, the credits get phased out really aggressively, basically gone for projects starting in 2028.
Wow, that's a strong signal.
A very clear signal. It creates a definite hierarchy. Oh, and it also suggests killing the hydrogen production tax credit, 45V, after 2025.
So favoring firm, dispatchable power and storage, it sounds like. And there's action from the executive branch, too.
Yep. The Department of Energy announced a new pilot program, trying to speed up testing for advanced reactors, cutting through some of the usual licensing red tape. The goal is ambitious. 3 privately funded test reactors operating by July 4th, 2026. And there's been talk of changes at the NRC, the regulator, also aimed at speeding things up.
Seems like a concerted push. And it's not just the U.S., right? You mentioned the UK earlier.
Absolutely. The UK is going big on nuclear revival. Not just the Rolls-Royce SMRs, but also that huge $14.2 billion investment in the large-scale Sizewell C plant. It's a two-pronged approach.
Building big and building small, basically.
And they're clearing the way for it. Reports say they're changing planning rules, getting rid of site restrictions, explicitly including SMRs, setting up a task force to streamline approvals. It's comprehensive.
Okay, let's zoom out globally. China. What's the latest there?
China just keeps going. Unbelievable pace. State-led nuclear expansion. The data shows they approved 10 new reactors last year. 4th year in a row doing that. That's about, what, $27.5 billion? They're aiming for 110 gigawatts by 2030, maybe 400, even 500 gigawatts by mid-century. And they build them fast, around 5 years, and way cheaper than in the West, maybe $2.7 billion each.
That scale is just hard to comprehend.
It really sets a benchmark. And another huge global signal, the World Bank. They lifted their ban on financing nuclear projects, so that ban had been in place for decades.
That is historic. What does that mean practically?
It means more international acceptance. And crucially, it opens up access to funding for developing nations who want to pursue nuclear. It's like a global recognition that, energy equity probably needs more than just intermittent sources. A major strategic shift.
And we're seeing other countries jump in, too.
Yeah, Kazakhstan is moving ahead with its first nuclear plants, partnering with Russia's Rosatom and China's CNNC, aiming for 2.4 gigawatts by 2035. And private investment keeps pouring in. Proxima Fusion in Germany raised a record 130 million. Investor confidence seems really high across the board, fission and fusion.
Okay, so the tech's moving, policy's shifting, money's flowing. Let's talk sustainability. The scorecard for this green hot core approach. Beyond just carbon, what about things like land use?
Land use is a really big differentiator. The research is pretty clear here. Nuclear, including these SMRs, has by far the lowest median land use intensity. We're talking around 7 hectares per terawatt hour per year.
Okay, how does that compare?
It's orders of magnitude less than, say, solar PV, which needs around 2,000 hectares for the same energy output, or large-scale wind. This means SMRs could potentially repower old industrial sites, brownfield sites, minimizing the need for new land, which is getting more and more contested. It's a huge efficiency advantage.
That's a point that doesn't get made often enough. What about water? Nuclear plants need water, right?
Traditional large plants can, yes. But the analyses show these advanced SMRs can be much better. Many use closed-loop cooling, significantly reducing water intake. Some designs can even use dry cooling, needing very little water at all. And remember that NUScale idea, turning desalination brine into hydrogen. That's actually a water-saving innovation in a way.
Right, repurposing waste. And life cycle carbon.
Still extremely low, around 4.5 kilograms of CO2 equivalent per megawatt hour for SMRs. That's right down there with wind and solar. Most emissions are from, construction and fuel processing, not the operation itself.
Okay, now the big one. Waste. Nuclear waste, always a contentious topic. What did the research find on SMRs and waste?
It's complicated. There are conflicting views. One study from 2022 suggested some SMR designs might actually produce more waste volume because of something called neutron leakage.
More waste? That sounds counterintuitive.
While the industry and U.S. national labs pushed back, they argue it's probably roughly comparable to traditional reactors, depending on the specific design, and that maybe the study oversimplified things. But it highlights this paradox, right? You have a small volume of highly managed, highly regulated nuclear waste versus the absolutely vast amounts of distributed, often less regulated industrial waste from renewables. Think millions of tons of old solar panels, wind turbine blades. Where does all that go?
That's a perspective you don't often hear, comparing the waste streams directly.
It's something to consider for a truly holistic view. And there is progress on the nuclear waste front. The U.S. Supreme Court recently upheld federal authority for temporary storage sites. Finland's deep geological repository, HALEU, is getting close to operation. Those are big steps.
Okay, and socioeconomic impacts. Jobs, communities.
Well, the potential benefits are significant. Big tax revenues for local areas, lots of high-paying long-term jobs. There's also talk about a just transition, retraining fossil fuel workers for these new nuclear jobs. But, public perception is still a hurdle. Concerns about safety, the long-term waste issue, transparent communication, and community involvement are absolutely key.
Right. So pulling all this together, what was the final picture? This idea of a complementary vision. High density and low density working together.
That's consistently what the research points towards. Policymakers increasingly see them as complements, not competitors. And that US OBBB proposal we talked about, it kind of forces that evaluation. It puts a premium on firmness, on reliability, looking beyond just the marginal cost per electron to the total system value.
Because wind and solar, even as they get cheaper per unit, still have that intermittency issue.
Exactly. Their fundamental nature means you still need backups, which translates to high total system costs if you want 247 reliability. You need massive overbuilding, huge transmission upgrades, lots and lots of expensive long-duration storage.
Which we're just starting to develop at scale.
Right. And then there's the siting challenge. Covering vast areas with panels or turbines often runs into local opposition, permitting delays. SMRs, with their smaller footprint, potentially have an easier time there.
So the future isn't all one thing or the other.
Doesn't look like it. The research suggests a balanced approach is the most likely path to net zero. Nuclear provides that firm, dispatchable baseload power, the foundation, while wind and solar act as valuable fuel savers, providing cheaper energy when the sun shines and the wind blows, using the strengths of each. It's an integrated system.
Okay, let's wrap this up. What are the main takeaways from this dive into green code, hot core?
I think the biggest thing is that the global energy landscape is shifting, really shifting,
Hmm.
towards this integrated strategy. It's being driven by these tech breakthroughs, SMRs, HLEU fuel, advanced storage, and reinforced by some pretty powerful policy signals and investment flows we're seeing worldwide.
Leading to a future that's hopefully more resilient, reliable, and uses land more efficiently, too.
That's the goal. Timelines. Looks like SMRs coming online through the early 2030s, HALEU supply sorting itself out in the late 2020s. Fusion, that's still further out, maybe 2040s and beyond for significant contribution. Challenges remain, of course, streamlining regulations, scaling up supply chains, figuring out the financing for these first-of-a-kind projects. It's not all smooth sailing.
Okay, final provocative thought for our listeners. Consider this. How does this shift towards high-density, often domestic energy sources redraw the geopolitical map?
Our nation's investing heavily in this, making a long-term strategic bet. A bet on energy independence, energy sovereignty for the 21st century.
Could this be a new fault line, shaping international relations, economic power for decades to come? Something to think about.
Definitely food for thought.
We always love hearing your thoughts. Whether you're watching on YouTube or listening on your favorite podcast app, drop us a comment. Let us know what you think about this deep dive into green code hardcore. What parts of this energy shift grab your attention the most? How do you see these high-density technologies shaping our future, our tomorrow?
Your perspectives really add to the conversation.
Thank you so much for joining us on this deep dive. Until next time, keep exploring the future.